Hello and welcome back to Engineers Olympiad, where learning meets success. As you know that we are doing the numericals of second chapter of surveying, that is theory of errors in surveying. So let's start. So the question is, in a tachyometric survey, the height h is calculated as h is equal to b tan theta. If the standard error of b and theta are plus minus 0.02 meters and plus minus 3 seconds respectively, when b is given as 100 meters and theta is 15 degrees, we have to determine the standard error of the calculated height and also the height. We'll apply the same formula for the propagation of errors, that the combined effect of the errors of the observed quantities on the computed or derived quantity is found by differentiating with respect to each of the observed quantities and then summing them up to obtain the total effect. All right, so let's begin. As it's given that h is equal to b tan and all right, h is equal to b tan theta, we have to determine the standard error of the height. So I may write it down as sigma h square is equal to, I'll differentiate it, b tan theta divided by b standard error in b square of it plus b tan theta with respect to theta error in theta square of it. All right, by calculations, sigma h square is equal to, this is how much? Tan theta square of it. This is, b is, tan theta is secant square theta, and this is theta, sigma of theta. Sorry, I'm write it. Please don't get confused. This is, all right, square of it. So I'll substitute the values and I may get my standard error of the calculated height. But before that, let me write it down over here. We know that 1 radian is equal to how many seconds? 206.265 seconds. All right. The error in theta is given as plus minus 3 seconds. I may convert it into radians. It is plus minus 3 seconds is equal to how much? It will be plus minus 3 divided by 206.265 radians. All right. Plus minus 3 seconds, I converted it into radians, and I know that 1 radian is equal to 206.265 seconds. So this is equal to 3 divided by 206.265 radians. All right. So let me substitute the values. Sigma h is equal to under root of tan theta sigma b square of it plus b secant square theta sigma in theta square of it. All right. Let me wrap it first and then substitute the values. All right. So sigma h is how much? Let me write it down once again. It is under root of tan theta sigma b square of it plus b secant square theta sigma theta square of it. All right. So standard error in the height is equal to under root. All right. Tan, how much is theta? 15 degrees. Tan 15 degrees. Sigma in B, how much? It's given as it's plus minus 0.02 meters plus B. B is how much? 100 meters. all right, multiplied by secant 15 degrees, square of it. Sigma in theta was plus minus 3 seconds. I converted it into radians and it is equal to plus minus 3 divided by 206,265 radians. All right, that's it. Tan 15 multiplied by 0.02, square of it. All right, and square of this as well. All right, so by calculations, standard error in height, the values, this is equivalent to 2.872 multiplied by 10 raised power minus 5, and this is equivalent to 2.430 multiplied by 10 raised power minus 6, and by calculation sigma h is equal to how much? Plus minus 5.581 into 10 raised power minus 3 meters. That means sigma h is equal to how much? Plus minus 5.581 mm. All right. So the standard error of the calculated height is equal to plus minus 5.581 mm. Now it also says also calculate the height. Let me calculate the height as well. It is given as h is equal to b tan theta. H is equal to b is how much? 100, and tan 15. By calculations, h is equal to 26.795 meters is the calculated height, and error in that is equal to standard error in that height is equal to plus minus 5.581 mm. So I may write that h is equal to 26.795 meters plus minus 5.581 mm. All right, so this was the question and we solved it by the same method, that how do we calculate the effect of errors on the computed quantities. If there are standard errors or improbable errors in the observed quantities, their combined effect in the computed quantity is given by differentiating. All right, let me rub it down first and let us do the next question. We're trying to solve as many questions as possible. All right, question number 2. Question number 2 says, the diameter d of the base of a cone is, let me write it down, the diameter d of the base of a cone is measured as 14.211 centimeters with a standard error of plus minus 0.002 centimeters. All right, the height h of the cone is measured, the height h of the cone is measured as 21.325 centimeters with a standard error of plus minus 0.003 centimeters. What is the volume of the cone? What is the volume of the cone and the corresponding standard error? and the corresponding standard error. All right. So the question is, the diameter D of the base of the cone is measured as 14.211 centimeters with a standard error of plus minus 0.002 centimeters. The height H of the cone is measured as 21.325 centimeters with a standard error of 0.003 centimeters. What is the volume of the cone and the corresponding standard error? All right, so let's solve it. We know that volume of the cone is given by how much? It is pi d square h divided by 12. Volume of the cone is pi d square h divided by 12. We will differentiate as we have to find the standard error of the volume. So sigma v square of it is equal to pi d square h by 12. This is with respect to, first we'll do it with respect to d, then standard error in d square of it, plus with respect to h, this is pi d square h divided by 12. This is with respect to, this is the standard error in h and square of it. By calculation, sigma v square is how much? This is equal to pi h d divided by 6, sigma d square of it, and this by calculations is equal to how much? It is pi d square by 12, standard error in height, square of it. All right, or I may write it down that sigma v is under root of pi h d by 6 multiplied by standard error in dia, square of it, plus pi d square by 12 into standard error in its height, square of it. All right, let me now substitute the values, but I'll rub it first. All right. So sigma v came equivalent to how much? Under root of pi h d by 6 multiplied by sigma d square of it plus pi d square by 12 sigma h square of it. All right. Sigma v is equal to how much? Let me substitute the values first. Pi 3.14 h. Height of the cone is measured as 21.325 centimeters multiplied by d. How much is my dia? The diameter of the base of the cone is measured as 14.211 divided by 6 and multiplied by standard error in the diameter. That is how much? With the standard error of plus minus 0.002 centimeters plus 3.14 multiplied by square of the diameter 14.211 divided by 12 and multiplied by standard error in height. Standard error in height is 0.003 centimeters, and I have to, this is the square of it and this is square of it. Use the long brackets, square of it and square of this term as well. All right, it's not visible over here, but it's square of it. All right, by calculations, my sigma v is equivalent to how much? 0.02612 All right. So my standard error in this cone, in the volume of this cone, is equivalent to how much? By calculations, it is equal to, let me write it down over here, it is equal to plus minus 0.35555 centimeter cube. All right. So this was the question and we solved it. All right. So this is equal to plus minus 0.355 centimeter cube. So volume, we have been asked to calculate what is the volume of the cone and the corresponding standard error. We have calculated the standard error, but we didn't calculate the volume. Volume, as it's given by pi d square h divided by 12, and this is equal to pi 14.211 square of it multiplied by 21.325 divided by 12. This comes equivalent to how much? 1127.475 centimeter cube. All right, this is the volume of this cone, 1127.475 centimeter cube, and the standard error came equivalent to plus minus 0.355 centimeter cube. So I may write it down. It's plus minus 0.355 centimeter cube. All right. So this was the question and we solved it. We have been asked to calculate the standard error of the volume of the cone and also the volume. All right. So we calculated it. Going on, let's do the next question. Question number 3. All right. Let's do the question number 3. And question number 3 is, the radius of a circle is, the radius of a circle is 20 centimeters with a standard error of plus minus 0.2 centimeters. What will be the standard error of its circumference? Standard error of its circumference. All right. So the question is, the radius of a circle is 20 centimeters with a standard error of plus minus 0.2 centimeters. What will be the standard error of its circumference? All right. So we know that circumference of a circle is given by 2 pi and r. All right. And standard error is how much? Standard error in circumference is plus minus k times sigma r. That means standard error in its radius. And we know that k is a constant, which is equal to 2 pi. All right. Therefore, standard error in circumference is equal to plus minus 2 into 3.14 into standard error in Radius, that is how much? 0.2. So standard error in circumference is equal to plus minus 1.256 centimeters. All right. So this was the question and we solved it, and we know from the general equations that if a computed quantity is equal to an observed quantity multiplied by a constant k, the standard error of the computed quantity is equal to the standard error of the observed quantity multiplied by the same constant k. All right, by this we found the standard error in the circumference of this circle. All right, moving on, let's do the next question. Question number 4. All right, so the question number 4 is this one. Determine the volume of box whose sides are as follows. We have to calculate the volume, and the box has the following sides: length, breadth, and depth. Length is how much? 20 plus minus 0.02 centimeters. Breadth 12 plus minus 0.01 centimeters, and depth is 10 plus minus 0.01 centimeters. So the dimensions of the corresponding sides and the standard error or the probable error in each of those sides have been provided. We have to calculate the volume of the box. Solution. All right. So we'll apply the same differentiation method and we'll calculate the combined effect of the error in each of the observed quantities. All right. So my volume of the box is given by how much? Volume of box is length multiplied by breadth multiplied by depth. So I have to calculate the volume. First I'll calculate the standard error in the volume, that is sigma v square is equal to LBD with respect to L first square of it, LBD with respect to B, then in B square of it, L, B and D with respect to D now, in D square of it. Sigma V square, this is how much? This is BD sigma L square of it. This is LD sigma B square of it. And this is ln B sigma in D square of it. So by calculation, sigma B is square root of BD sigma L square plus LD sigma B square plus LB sigma D square. All right. By substituting the values, let me substitute it over here. B, how much? 12. D, how much? 10. Sigma L, how much? 0.02 square of it. Plus L, how much? 20. D, how much? 10. Sigma B, how much? 0.01. All right, square of it, plus L, how much? How much is L? 20. How much is B? 12. And how much is sigma D? 0.01, square of it. All right, I substitute the values from the given parameters, and by calculations my answer is equal to, let me rub it first. All right, by calculations my sigma V is equal to, that is my sigma V is 3 point plus minus 3.93 centimeter cube. All right, so sigma V is plus minus 3.93 sigma cube. All right, but besides that, it had also, question says that you have to calculate the volume of the box. Let me calculate the volume as well. L into B into D, that is 20 into 12 into 10. All right, 20 into 12 into 10, that is equal to how much? 2400 centimeter cube. So I may write the volume of this box is 2400 centimeter plus minus 3.93 centimeter cube. All right, moving on, let's do the next question. All right, this is question number 5. Question number 5. Question number 5 is, if the standard error of a backside reading from a set up of a level is plus minus 0.01 meters, and the standard error of the foresight reading from the same setup is also same, plus minus 0.01 meters. Determine the standard error. Determine the standard error of the difference of elevations. All right. So the question is, if the standard error of a backside reading from a setup of a level is plus minus 0.01 meters, and the standard error of the foresight reading from the same setup is also plus minus 0.01 meters, determine the standard error of the difference of elevations. The standard error of difference of elevations will be, since we know that in case of either subtraction or addition, my general formula is same. So the standard error for the difference of elevations will be under root of summation of square of the standard error in backside plus foreside. So standard error in elevations is equal to how much is my standard error in backside and foreside? Both are same. 0.01, this is plus minus 0.01 meters square of it plus 0.01 meters. So by calculation, the difference, the standard error of the difference of elevations is equal to plus minus 0.0002. So sigma E is equal to how much? 0.014 meters. Alright, standard error in the difference of elevations came equivalent to 0.014 meters. Alright, moving on, let's do the next question. Question number 6. Question number 6. All right. A line is measured in 5 sections. And the length of the sections together with the standard error in the length of each sections are given below. In the length of each section are given below. All right. Now we have section length and the standard error. Section length and the standard error. It's 1, 2, 3, 4, and 5 sections we have. Length here is 231.451 meters. 425.329. 321.612. 252.328 and 125.416. Standard error in each length are given as plus minus 0.041 meters. Next one is plus minus 0.052. Then we have 0.045. After that 0.032. And the last one is 0.012 meters. 0.012 meters. Determine the total length of the line. That is our question. We have to determine the total length of the line. Alright, so we have been given lengths and the standard errors. We have to determine the total length of this line. Alright. Alright. we know that the total length of this line is equal to summation of this, but we have to calculate the effect of the standard errors in each of the observed quantities on the combined quantity or derived quantity, and that is given by differentiation. And by the standard or the general rule, we know that in case of either addition or subtraction, it is equal to standard error in length is equal to summation of the squares of the standard errors in each of the readings, that is plus minus 0.041 square plus 0.052 square plus 0.045 square plus 0.032 square plus 0.012 square. All right, by calculation, sigma L is equal to plus minus 0.087 meters. How much? Plus minus 0.087 meters. So the total length of the line is equal to how much? Total length of sum of all of them, that is equal to 1356.136. This is the summation of the lengths in each section, and this comes equal to 1356.136 meters, and the standard error in the length was given by the general expression for the propagation of the standard errors in case of addition of the quantities, and that came equivalent to plus minus 0.087 meters. So the total length of the line is equal to 1356.136 plus minus 0.087 meters. All right, let's move on and do the next question. Question number 7. This is our question number 7. And let's see what does the question number 7 say. All right. We're trying to solve as many questions as possible, and the question number 7 is this. All right. The dimensions of a rectangular field are measured with a tape. All right, the dimensions of a rectangular field are measured with a tape and found as follows. It is equal to 350.00 meters plus minus 0.05 meters, and breadth is 240 meters plus minus 0.03 meters. We have to measure area. What is the area of the field along with its standard error? What is the area of the field and the standard error of the field? I mean standard error in the area of the field. All right, standard error of the area. All right. The dimensions of a rectangular field are measured with a tape and found as these. What is the area of the field and the standard error of the area of this field? All right. So let's solve this question. All right. Area is given by length multiplied by breadth. All right. Standard error in area square of it will be given by, first with respect to L, sigma L square of it plus with respect to B square of it. All right. So sigma A is given by how much? This is B sigma L square of it plus this is L sigma B square of it under root of this. All right. Now I'll substitute the values and I'll get the answer. Sigma A is, how much is B? 240. How much is sigma L? 0.05 square of it. How much is my length? 350. How much is my sigma B? 0.03 square of it. By calculations, sigma A is equal to how much? Plus minus 15.94 meters square. All right, by calculation, standard error in the area of this field is plus minus 15.94 meters square. And how much is the area of this field? 350 cross 240. That is 84000. All right, meter square. So I may write that area of the field is how much? It is 84000 plus minus 15.94 meter square. All right. So this is the area of the field, 84,000 plus minus 15.71 square meter or meter square. All right. Let's move on and do the next question. All right. We're trying to solve as many questions as possible. Theory of errors in surveying is a very important chapter, and this will also build the concepts for the next chapter of surveying, that is linear measurements. All right, so let's do question number 8. Question number 8. Question number 8 is, all right, this. If the standard error in length of a square 1 meter cross 1 meter is plus minus 0.1 centimeter, the standard error of the area will be, the standard error of the area will be, all right. The question is, if the standard error in length of the square 1 meter cross 1 meter is plus minus 0.1 centimeters, the standard error of the area will be, all right. We know the general expression for the propagation of the standard errors in case of product of the quantities, and that is we have already done this while we were doing what? Propagation of standard errors. And this is equal to this. In case of a product of a quantities, the standard error is given by this expression. So here I have to calculate the standard error of area. I may substitute my values. This is plus minus. Since this is in centimeters and this is meters, I'll convert them into centimeters. 100 cross 100. Sigma A is 0.1 divided by A is, this is A and this is B. All right, please do not confuse yourself. One side and the second side of the square. All right, 100 square of it plus, both have the same standard errors. All right, all right, 0.1 divided by 100 square of it. By calculations, this is how much? This is 0. So sigma A is plus minus 14.14 centimeters square. We have been only asked to calculate the standard error of the area, and the standard error of the area of the square is equal to plus minus 14.14 centimeter square. All right, moving on, and let's do the question number 9. Question number 9 is, if the standard error of each tape length is plus minus 0.01 meters, the standard error in 9 tape lengths will be, the standard error in 9 tape lengths will be. All right, so the question is, if the standard error of each tape length is plus minus 0.01 meters, the standard error in 9 tape lengths will be. So this is the question of, this is the case of addition of the quantities. All right, so standard error, general expression for that is standard error in the 9 tape lengths will be how much? Plus minus square root of the standard error in each of the tape lengths and then summing them up. All right, so this is given by 0. How much is the error in each tape length? 0.01 square plus 9 times, but the general expression in this case will be that plus so on 9 times. But by general expression, the sigma in length will be standard error in each multiplied by square root of the n times n number of measurements that we are taking, or sigma is equal to sigma n raised power 1 by 2. All right, this is how many times we are actually calculating the effect, since this is the case of the addition of quantities, and the general expression says that if sigma A is equal to sigma B is equal to so on is equal to sigma, the general expression becomes this. That means by general expression, the standard error in the tape lengths will be equal to how much? Standard error in 0.01 plus minus multiplied by square root of the number of times I am taking my measurements. I have to calculate in 9 tape lengths. So by calculations, this is how much? plus minus 0.03 meters. This will be the standard error in 9 tape lengths. All right, how much? Plus minus 0.03 meters. Or the alternative method of doing this was the same one. I had to do this, then I had to do it 9 times, 0.01 plus 0.01 plus so on 9 times. All right, so we use the general expression, and the sigma was equal to plus minus 0.01 multiplied by under root of 9. So sigma in 9 tape lengths came equal to plus minus 0.03 meters. All right, moving on, let's do the last question, question number 10. Last question for this video lecture. All right, let's do this. Question number 10 is, if a quantity A has a weight of 3, if a quantity A has a weight of 3, then the weight of A by 3 will be, then the weight of A by 3 will be, as per the law of weights, if any quantity has weight, let's suppose x, then if we'll divide that quantity by some constant, then the weight of the quantity becomes the same weight multiplied by the square of it. All right, here quantity A has weight how much? 3. So I am dividing it by 3. Constant is 3. Then the weight of the new quantity A by 3 is equal to weight of A, that is 3, multiplied by the square of the constant by which we are dividing it. That means square of 3. So the weight will be 27. If the quantity A has weight 3, A by 3 will be having a weight of 27. This is as per the law of weights. All right. With this, we conclude today's video lecture. Thank you for watching.